Picture this, you've just pushed this amazing new feature to production, you're really proud of it, and then you instantly regret it when everything breaks. If that's you, you might need automated testing. I find a lot of the videos on YouTube focus on specific frameworks or languages and how you do testing in those, but this video is going to focus on the philosophy behind the three major types of testing: unit, integration, and end-to-end tests. We're going to go through when you should use them, what they're for, and then we're going to do specific examples in a super simple sample project I've been working on. So if you're a junior developer who doesn't know anything about automated testing, or a senior developer just brushing up on your skills, this might be the video for you. Anyway, let's get started. So I've created this simple form here for a newsletter. It lets you type in your email, subscribe, which causes this alert to pop up thanking you for joining the newsletter, as well as sending off an API request. So that's what we're going to be applying our tests to, but before we do that, let's go over an overview of testing as a whole. Your tests are going to live in your code base alongside your code, so that way when you update the code, it's easy to update the corresponding test. The test names are going to follow a specific naming convention, depending on whatever test runner you're using. So Jest has .test, Vitest starts with test underscore, and then Go uses underscore test at the end. It really depends what framework you're using, but it's used so that the test runner, the thing that runs the tests, knows what to run as code and what to run as a test. In our test file, we're going to define a test suite, a logical grouping of tests to test one particular thing, so testing a particular feature, for example. It'll have a human readable name, so it's easy to identify when we see it in the command line, and inside that we'll define some test definitions. They'll have a human readable name for the same purpose, and it will define what scenario we're testing. So this will be testing with invalid input or a particular type of input to see what happens. Inside the test, it'll generally follow the AAA structure or AAA structure. I'm not really sure because I've only ever seen it written down. It starts with arrange, where you set up the environment, the things you need to be able to run your test, and then you take an action that you are testing and you assert that the thing you wanted to happen has happened. This comes from test-driven development, TDD, which is basically where you write failing tests first, you then write your code to pass those tests, and then you refactor everything to clean it up. It's a methodology, a way of bringing tests into your dev workflow. There's other ones like BDD, which has its own version of AAA, given, when, then, but really these methodologies aren't that important. Your team will have decided how they integrate tests into your dev lifecycle, so go with whatever they've suggested. Anyway, on to writing our first actual test, the unit test. Units are small, isolated, independent parts of your code, with the idea that if you have all these different units that compose your larger systems, if you've tested those, you can have more confidence in the reliability of the whole system. To run my test, I'm going to need a test runner as part of my testing framework. I'm going to be using Jest because that's what I'm most familiar with, but for whatever purpose and language you're using, there'll be a testing framework out there for you, so you can just go ahead and Google that. Here I have a function to run validation to check what the user has typed in is a valid email. We're going to write our first unit test for this unit. Unit tests, to me, are most useful when you're writing something that has a clear input, clear work that should be done with a clear output. Like if you're writing a sorting algorithm, for example, that would be super helpful. You know what the input is, something unsorted, the output should be sorted, it's very clear to test that unit. Our validation function here is a great example of what I like to test, because it's a small unit, it's clear when it should pass and fail, and it's deterministic. It's not going to work sometimes, fail other times. It should also be a singular unit without depending on other stuff to work first. By the way, I know writing this with regex is kind of stupid. Bear with me. So I'm going to call my test suite newsletter email validation schema. With a test case, email schema should successfully pass with a valid email. I'm going to import the schema I'm using from the other file. That file is called email schema, so we're going to call this test email schema.test.ts. And in here, I'm going to run a valid email into that schema and check that when it passes the input, it returns that it's valid. This test is a good unit test to me because it's fast, it's repeatable, it's deterministic, and it's always going to work with the same input for the same output. You'd likely move on to writing some more tests in here as well, so different scenarios, different things that you can type in and ways of testing whether it would fail. And then you want each of these tests to run in isolation, not depending on each other, but that's not really a problem here. Now we'll go ahead and run our tests with our test command. For me, that's npm run test, and it'll show that our tests are passing. It also outputs a lot of other information you might see. this is how many lines of code are being tested. It's called test coverage. Test coverage basically is a percentage of the lines that are covered by tests. So if you had an if statement that was never entered by any of our tests, then it wouldn't be covered and wouldn't contribute to that percentage. Now if we wrote a test that entered that branch, it would then contribute to boosting our test coverage. In my opinion, this is just my opinion, someone might say something different, more tests don't always equal better code. If we look at the code here, I'm using regex to do my validation, but the validation library I'm using, Zod, has a built-in email validation. If I switch to using that, then we can kind of ask, what are we really testing here? I mean, Zod has its own tests internally to check that these things work, so I'm really just building tests to test their logic. It doesn't really make much sense. Other people might disagree though. If you disagree, let me know. Unit tests are really useful because now that I've changed the internal logic, I can rerun the test and check that I haven't introduced a regression causing an error. We can see that I haven't, so let's move on. So we've tested the units of our code, but how do we know they work together to do the things we want them to do? Well, now we're going to introduce integration tests. These are going to check that the components we have work together to do what we want them to do. So in my form, I'm going to check that the schema validation thing that I just did works and is able to integrate with the UI, create the form, submit the form, send off the API request, and it all sort of works as a system. For that, we're going to have to actually do some UI work, interact with the screen. So we're going to use React testing library to interact with the UI elements. So we're going to do what we did previously, test suite, test definition, and then we're going to render our form and get elements within the form by the ID. We're going to type in a value, and just like how we did with our unit test, check that it works, but now with the UI elements included. And then we also want to check it sends off the API request, but we don't want to add test@test.com to our mailing list, right? So we're going to have to use a test double. Test doubles are stand-ins for real dependencies or components that you don't want to test as part of your test. There are 5 major types, like dummy, which is used to fill in parameter lists but they're never actually used in the code, like passing none or a placeholder. Fake, something with a working implementation but simplified for testing, not suitable for production, like SQLite instead of connecting to the actual database. Stub, which is an object that stands in for a dependency or component with a predetermined response, so maybe always returning the same data regardless of the query. Spy, which is like a stub but records interactions with the dependency, so you can check at the end, was it only run once with specific parameters? Finally, the one we're going to use is a mock. Almost a dynamic stub, it provides predetermined responses based on the specific inputs, so it fails if you aren't supplying the right parameters to that dependency. For me, I'm going to mock my API so that when I send a valid email, it sends back a 200 response and says that that email has been added, but then it doesn't actually add it, right? If I go ahead and run my tests with the same test command for me, this file will get picked up and we'll see the test pass. So you can use test doubles in unit tests and integration tests. It just depends. You should be using test doubles when you don't want to test that part. So unit tests would be anything outside the unit. The integration test would be anything outside of my specific integration tests. So here, I'm not testing the API. This is a front-end integration test, really. If you wanted to include your database in some way, that would still be an integration test. But for me, I'm using an external API mailing list, so it doesn't really make sense for me to test it. If you did want to test adding them to a database though, you could maybe use a fake and then have a SQLite database instead of a real Postgres database host somewhere. So all our systems work together independently, so we'll combine those into our full actual product. We'll run that and take actions as a user would, and that's an end-to-end test. Probably the most valuable, but also difficult to run. So for this, we need to actually run our application and interact with it through the browser. So we can't use Jest that we've been using for our integration tests and unit tests, because this requires an actual environment. So I'm going to use Playwright. This is going to let me scroll through stuff, click stuff, type stuff. It's a completely different tool from using Jest. You'll probably find that you need to use something different as well in whatever language you're using. So I'm going to test something pretty similar to what we tested in our integration test. I'm going to type in a valid email, press submit, but I'm also going to check that my alert works. And also because I'm doing this through an actual browser and I'm using Playwright, I can check in different browsers the alert pops up in the same way. And that's the difference between integration tests and end-to-end tests. Remember that end-to-end tests are basically a one-to-one copy of what your product is going to be. with maybe some changes in using fakes. But other than that, it's the closest thing you're going to get to a user actually using it and causing problems. So how do you combine these tests to get the most out of them? Well, the common consensus is the testing pyramid. It's a lot of unit tests, less integration tests, and even less end-to-end tests. But I don't really subscribe to the testing trophy. I subscribe to Owen from work. That's terrible. My problem with it is that I find unit tests most useful when there's a clear input, clear output, and a really complex algorithm in between. And you won't really find that in the average React app. Instead, you just find yourself writing very trivial, simple unit tests just to hit a test coverage, but in the end, not really feeling any more confident about what you're doing, and that feels to me what's most valuable about tests. Instead, I prefer the testing trophy, which starts off with a base of static tests, so linters and type checkers, and then has a smaller amount of unit tests for really specific, difficult, hard functions, and then a lot of integration tests. Because let's be real, the average React app is just making sure things work together nicely. Don't get me wrong, you should be using unit tests, just to cover very specific, complex functionality and avoiding mocks where you can. Finally, a small number of end-to-end tests that are maintained religiously. Tests aren't free, you have to maintain them and work on them, and end-to-end tests are annoying to work on and flaky, but super valuable. What can happen is people write a lot of end-to-end tests to test every bit of functionality, but they're really flaky, and then just don't work, and people say, oh, that test always fails. If you have one test failing, it kind of reduces the whole point of testing. It should be like, oh, I feel confident that I can push this code, and if bits are always breaking, you don't really have as much confidence, right? So maintain these tests religiously. If you don't like either of these, the testing trophy or the pyramid, there's like a testing honeycomb out there, there's all sorts. Really, I'm going to get a lot of flack in the comments probably, because people like to debate all this different stuff. Really, whatever works for you to make sure that when you press push that you have the most confidence, that's what you should be doing. For your project, it might be a lot of unit tests. For me, it's not. Finally, tests are most useful when they're run automatically as part of your dev lifecycle. The most common place you're going to see this is in a pull request. Looking at Supabase, which is a popular open source tool you might use, we can see they have a number of automated tests running anytime someone makes a pull request. If their test fails, they can't merge their PR until it's fixed. So maintainers don't have to manually open the branch, run the test locally, and then check it works and allow them to merge. It all just allows you to continuously integrate and continuously deploy. CI/CD. That's a thing, by the way, I didn't just make that up. So in our code, we'll just define a simple GitHub action, and that's going to run the unit tests we've just set up. And we can have it generate some simple artifacts, which is where it points to files when it makes the pull request, so you can look at the test coverage we mentioned earlier if you're curious. So those were the major types of test, but there are plenty more out there. Snapshot, smoke, component, whatever works for your project, I'd really recommend looking into. But unit, integration, end-to-end are probably going to make up the bulk of the testing that you do. Hopefully this has been useful for someone out there. I can't wait for people to tell me that I'm completely wrong about my testing takes. Please do in the comments, but hopefully this has been useful for someone. Anyway, thank you. That was terrible.